Okay, here we're going to look at question C. Now, I don't know, I mean, you probably already know that the graph of y equals x cubed looks like that. And therefore, the only point you can really mark on it is the origin, 0, 0. It doesn't have a maximum, it doesn't have a minimum. Last lesson, we looked at finding the point of inflection, and we found that the point of inflection is here at 0, 0. Let's just let's just prove that it doesn't have a maximum or a minimum. So the first derivative is 3x squared. If 3x squared is equal to 0, then x equals to 0. Okay, so we've got a maximum or a minimum, x equals 0. So let's find out whether that's a maximum or a minimum. Well, if we get if we differentiate again, we get 6x. Now, if we find out what the second derivative at 0 is, then 6 times 0 is 0, which is neither positive or negative. So it's not a maximum or a minimum. And therefore, it's important to bear in mind that in an example like this, if the second derivative at that point is neither positive nor negative, then probably it's a point of inflection. Okay, but you do need to, if you didn't know what the shape of the graph is, then you still do need to check that just before that value, the second derivative is negative, and of course it is, and that just after that value, that the second derivative is positive, which of course it is, and therefore it is changing from concave down to concave up, and it's a point of inflection. Okay, so that's just a really quick example, and hopefully it just sort of confirms a few things that we should already know. And there's what it actually looks like digitally. This example is a little bit more involved, possibly.